Okay, so welcome to the very first English-based meeting of agilelabs community. Welcome everybody. I'm more than happy to welcome our guest, who is Vasco Duarte, who made no estimates idea available for all of us, and would like to share more details with us and tell us why those estimates are not working and what is wrong with them and what actually do about that. The format of this meeting is like this, but we will hear some insights about the topic, pretty short introduction, so just the meat of the topic. And later on, we would like to invite all of you actually to discussion, to ask questions, especially that I think it is pretty unique opportunity to ask the question to the author. Yeah, be brave, ask any question you may have. Please take part in the discussion.
All right. Hey, everybody. First of all, thank you very much for the invitation, Pavel. It's a pleasure to be here in your community to share some of the ideas that I've been working with since 2008, although I did only have my first public no estimates talk in 2012. I started writing this. I went back to the blog to see what was the first blog post that I wrote, and it was around 2008. And it's funny because at that time, I said something that most people repeat to me even these days. Estimations are really good anyway, so why don't we just do them and forget the numbers? So if you guys already have that question planned, please let it come. But that's what I wrote in 2008, pardon me. And then after that, I changed my views. I don't think we should even be doing that, but we'll talk about that later. First, I want to tell you that this presentation is about tackling one of the biggest questions I have, which is how can we make estimations better? And my answer to that is it's impossible. It's not possible. And I'm going to try to prove that statistically today with a few examples. So why all, meaning all, everyone, attempt to improve the estimations have and will continue to fail. And of course, we'll talk a little bit about what to do instead, and hopefully through the questions, go a lot deeper into that. Now, to get us started, I have just posted on chat the link to the book. So if you want to have the book, you can go there to that link and sign up and get the book in an email reply. Now on with the show. So a recent study, it's 2016, if I remember correctly. No, actually 2002, there we go, 2002. A recent study by the Aalborg University of 258, so quite a lot of projects, international transport infrastructure projects between 1927 and 1998, so there's a lot of time there, found that the actual costs were on average 28% higher than the estimated costs. This is an important number. And that in 9 out of 10 of these projects, the costs were underestimated, resulting in a cost overrun. Now, what this tells us is something I've been arguing for a long time. Full disclosure, I am a certified project manager, so I have a lot of years of project management under the belt, and that's why I think it doesn't work. That's basically what I'm saying here. Projects are not the best tool if what you want is to contain costs or hit a particular deadline. And this is what that article clearly shows. So in other words, if you were thinking of running a software project as some sort of an investment, projects are just a bad investment strategy. It just doesn't work for what we want. So let me show how bad. Let's take an hypothetical project. Let's say that this project has only 10 tasks, kind of a toy project, and each task has a 1-day duration. So like 10 tasks, 1 day, one at a time, 10 days. That would be the ideal duration. That's the ideal duration. So what happens if we ask a computer to run this project 1,000 times based on an empirical distribution, meaning something that closely replicates the results out there, which is the Weibull distribution. Now, we could argue that the actuals in a project follow a slightly different distribution. That's okay, we can argue that. Weibull distribution is a very optimistic one when it comes to projects. So it's in any case a good case, or not the best, but a good scenario in terms of project actuals. So the computer did diligently replicate this project 1,000 times and found out that the distribution went from perfect to around 15. So 15 means 1.5 times the estimated duration. This is, don't forget, a 10-task project. So it's a toy project, if you will. So as you can see here, the probability of hitting the estimated duration is quite low, right? So if we look at this, the probability of the perfect estimate happening, even allowing for a 10% deviation and still counting it as well estimated, that would be about 4.6%. This is an important number because this project is so small, and when we go into a much bigger project, so go from a 10-task 10-day project to a 100-task 100-day project. Now, in some organizations, a 100-task 100-day project would also be a toy project, and that's okay. But I want you to see how much worse it is if we go from a ridiculously small project to a quite ridiculously small, but not as ridiculously small project. And here's the error when the computer goes and estimates a 100-task project 1,000 times. So the minimum project duration, so the best case scenario, minimum project duration is 116.8. Remember that it was supposed to be 100 for the perfect estimation, but this is the minimum project duration, and that's a 17% overrun. This number is also important because according to estimation proponents, a project is well estimated when it is within 20% of the original estimate. And here, for a very small project, so a 100-task project, it's 17%, and that's the best case, right? If you want to be 50% confident that you get the right estimate, then you have to go 25% higher than the original estimate. The probability, this is the most important, the probability of a perfect estimate on this size of a project is 0. This is very important because that's what we are being asked to do when we are asked to estimate projects of, any significant size. So how quickly does it get that bad? So we saw the results for 10 tasks and for 100 tasks, right? So that's the results that we saw. But how quickly does it get that bad? Or in other words, is a project fragile to the size or number of tasks? Fragile here has a specific meaning. It means that the errors grow much faster than the size of the project. That's what fragile means, right? So does it? And yes, this is the probability of a perfect estimate, which for one task is, of course, 1 or 100%. And if we start following this line, we will see that when we get to 30 tasks, the probability of the perfect estimate is very close to 0. And that's just 30 tasks, 30 tasks, not 100 tasks that we already saw the probability is 0. This is now a problem for us because this tells us that the harm of estimates grows exponentially faster than the size of the project. This is very important from an management and, of course, investment strategy perspective. Estimation proponents want us to believe that the errors are linear, right? So they kind of wash out most of the time, but in any case, they are linear. So the errors grow, but they only grow linearly to the size of the tasks, and that's not the case. We just saw that there's a huge difference, and that difference is the impact of using estimates in any non-trivial sized project. Now, the project failure because of estimates becomes a fat-tailed process. What that means is that the errors have a much bigger impact as the project grows. So as I try to illustrate here, for example, if you have a 5 task project, the probability of a perfect estimate is almost close to 20%. But if you have a 10 task project, the probability is probably around the 5% mark. So there's a big difference, right? That's what a fat-tailed project means. And by the way, this is what this article illustrates, if you want to know more about it. So this means that what we just saw here, based on a simple simulation, done with a computer model, is then borne out by the research that is out there. And I won't bother you with all of the examples of bad projects that went really bad, but I do want to talk about a new solution to the be on time or be on budget problem. And we already know this from telecommunication networks, right? Telecommunication networks exhibit certain properties. They are systemic properties. You can pretty much predict the throughput of a computer network. There might be glitches, and we all know how sometimes networks crash, but overall you can predict their performance. And when I look at the items completed by a software team over 3 years, I can do the same, right? This is 3 years of data, and I can quickly draw a couple of lines, even just by eyeballing the graph, and I can say that the performance of this team, so the number of items completed per unit of time, will be within these lines. Now I can do this mathematically and get an even better understanding of their performance capabilities are, but the idea is that it's entirely predictable within a certain range. And this gives us proposition 1 of our solution. Our rate of delivery will be the same over time unless significant changes happen in the team or the system. And by the way, this is the same in computer networks, right? Like what happened in Facebook a few months ago, somebody switched off one of the load balancers and that crashed all of the other servers, right? So that's obviously something significant changed, therefore the performance of the network changed. And proposition 2, which is what I propose we know, is that how many items are in the backlog. Now, if we know these two things, we know our rate of delivery and we know how many items are on the backlog, we can quickly do a burn down, right? Like you are all familiar with the burn down. You have here the number of items. Here you have dates, so time, growing in this direction. You have the ideal delivery rate, which is never true, obviously. And then you have the actual delivery rate. You have this line that goes, up and down, a little bit jagged line. New stories are discovered, some scope is removed, add some scope, and then we also have this, we found out we're late, so let's cut some scope, right? So we have this opportunity to follow the delivery rate of a team. Now, this is important because once we know the rate of delivery, no matter where we are, we can always trace the optimistic delivery rate based on that graph and the pessimistic delivery rate. So these lines are based on first the optimistic line here and then the pessimistic line here. And you know that most likely you will be somewhere in the middle. This is important because it allows us to understand where our delivery will be. And here's the key thing. We can do this at all times without bothering the team, without interrupting them, and without having endless discussions about the details of features we might never implement. And that's really the key point here. Now, in the book, I go into a lot more details. In fact, the book is all about the questions I always got asked when doing a no estimate presentation. So you will learn how to establish a trustworthy backlog, how to track the rate of delivery, how to use data points to forecast without estimates, and of course, finally, the most important one, how to deliver on time by accepting that scope management is the only tool that we have for the delivery on time problem. In fact, if we go here, we know that if the optimistic line is too late, let's say it ends up here, we know that the only way to deliver on time is to cut scope so that the optimistic line is somewhere closer. The same thing happens when we add scope. Let's say you're here and somebody added scope and now you're here. Well, if I trace the lines, we have the pessimistic line and the optimistic line, and now you have your delivery, expected delivery dates, right? The minimum or optimistic and pessimistic. So that's really the most important tool that I want you to keep in mind from this presentation, is that no matter how you forecast or how you discuss estimates within your team, don't forget that the most important thing, and I talk about this in the book, is to manage the scope aggressively and from the start. And a tool like this helps you to do it from day one, assuming that you're respecting the propositions we reviewed, that the rate of delivery will be the same unless significant changes happen to the team or the system. And we know at all times how many work items we have in our backlog. So that was a quick intro to what I hope to be a lively and insightful discussion with you guys. So Pavel, take it away.
Thank you very much. And yeah, I would like to open just question, answer, and discussion.
And by the way, while the first person comes with the question, I just posted the link to the book on the chat. So if you want to follow up on that and read more about what I just discussed here with you guys as an intro, then please go ahead.
So maybe one more thing, because I was explaining stuff and in the meantime some people joined us, so maybe I will quickly repeat. But as you already saw the presentation from Vasco, right now is the time, pretty unique opportunity to ask question directly and have answer, and also discuss stuff right now on the meeting. And this meeting is recorded. If somebody don't want to be on the video, please contact me afterwards, and we will make some magic to not show who don't want to be shown. Okay, so this is the time for you, and really unique opportunity to ask question and discuss.
I think Yaroslav had a question.
It did. So first of all, thank you, Vasco, for interesting presentation, and thank you for attending. My question would be, what you showed us when you said about the capacity, or basically the throughput of the team. You had like 3 years of data. So first of all, I envy you having a team of 3 years, stable team, unless it was something different. But when I think that would be the crucial problem, because I believe that here you're still talking about kind of a yesterday weather, are you not? And I would like to understand how much data, previous data, do you need comparing to, for instance, using traditional velocity to have a solid results and to be able to basically predict something based on it. 3 years, it's a lot, but I think most of us don't have such a luxury of having 3 years of data for a particular team.
Yeah, that's a very good point, Yaroslav. So two things. First, I showed you 3 years, so there would be no objection saying that, oh, there's too little data, you don't really know what's going to happen next. And obviously, as you can imagine, over 3 years, there's a lot of changes that happen, right? Like, you know, there's vacation periods in there, there's people sick in there, and so on. The idea that I wanted to show you is that even just by eyeballing the data, you can see the same pattern you see on a network throughput. And that's very important. That's insightful. That's a tool we can use. Now, the second question you had is, is this throughput or is this velocity? You didn't ask this explicitly, but you mentioned the two, so I want to make this clear. Velocity, as used in many teams out there, is actually related to the story points delivered per unit of time. And I want to be very clear, we're not using that kind of velocity. I'm using throughput here, as you correctly stated at some point in your question. and not velocity in the sense of number of story points delivered per unit of time or per sprint. Because actually the data you have on the screen at the bottom is items completed per day. Now, obviously, I'm sure you will ask, well, that must be quite a team because they have so many items delivered per day. You know, you can see that some days it goes up to 20. The idea here is that the team does something else that is very important. Whenever they are unsure about delivering an item in one day, they break it down so that at least they can deliver part of that item, if not the whole item, in one day. This is very important. What they are doing is that they are explicitly clarifying scope as they go. And this tells you another thing, which is that the backlog of this team is constantly changing, right? So if I take this picture as an example, the backlog is actually going like this. And why this is not a problem for this team is that they then do something we also reviewed in the last slide that I reviewed with you. They are doing active scope management. So every day, or at least every couple of days, they are looking at the backlog for the sprint and they're saying, should we remove some stuff? And of course, what they removed, it goes back to the product backlog. This is very important because a lot of us, and myself included some years ago, expect that the backlog be a lot more static than this. In fact, if you read through most of the estimation and planning books in the Agile community, they are based on the fact that when you write a story, it stays the same. This is a ridiculous thought. And the reason for that is very simple. When you start doing the work, you discover things that could not have been found out in refinement, because when you start doing the work, you're looking at the code, right? That's not information that is available in refinement unless somebody has the whole code base in their memory. Unlikely. This is very important. This particular team, for which there is 3 years of data, and that's correct, that's not going to be the case for many of you. This particular team is doing something that is critical. They're not looking at stories as requirements. They're looking at stories as tools they use to manage their work, both in scope as well as in time. Right? This is a totally different paradigm if you think about it. The story is not a tool of the PM, the story is a tool of the whole team. Right? And we can talk about techniques to decompose stories, break them down, and so on and so forth. We can talk about that later. And I think there was a third question in your statement, and I'm afraid I might have forgotten it. Pavel, can you remind me, what was the third question? Oh, now I remember. How many sprints of data do you need? So my own experience is 3 sprints are enough to get started. Now, I'm not arguing that you should only get 3 sprints. I'm arguing that it's enough to get started. And then the other question will be, you haven't asked this, but other people have asked, well, but 3 sprints is still 6 weeks. Well, then have the first 3 sprints to be a couple of days. Do 2-day sprints for 3 2-day periods and have an understanding of your velocity, in this case, your throughput, and start using that because you can immediately project that into the backlog. And that gives you a very good understanding, even with just 3 times 2 days, of what's possible to deliver in the near future. And then once you have a good, solid understanding, you can increase the sprint duration. Now, some teams are not mature enough to do that. That's fine. I wouldn't require this from most teams anyway, but I'm just giving you an example of how you can change the constraints of the system to give you the information you need so that you can finally make decisions. At the end of the day, the only decisions we can make to deliver on time are not better estimates, they are scope management decisions. And for that, you need to know the rate of delivery and the size of the backlog. And that's the only 2 pieces of information you need.
Thank you a lot. Well, that raised, of course, many other questions, but I will allow others to ask theirs. Thank you a lot.
There are some questions on chat. So, Marcin, do you want?
Yeah, I can read. So
Yep.
one is from Jacek Kwaśniewski. How do you actually sell this idea to client who comes to you with their idea for product and expects you to make some kind of fixed price and time offer to work with you?
Yeah, so first of all, don't sell this idea to anyone. The advice I give everybody is do it in one of your projects. Preferably, do it in one project for which you already have the data available. Let's say you have 10 sprints of one team. Pick the first 3 or the first 5 sprints of that 10 sprint series and use that to predict the output of the next 5 sprints or the next 7 sprints and see how it works for you. That's the first advice. Like, make sure that you believe in it. The reason for that is simple. Once you stop believing in estimates, they disappear. They are no longer relevant for you. And you don't need to convince anyone. In fact, that's what I do. When the teams that I work with decide to estimate, I'll leave the room. I'll say, I accept you need the estimation for your own purpose and for your own goals. I don't need that, so I'll go and spend my time doing something else.
Thanks. I think it answers the question. Jacek, if you would have any additional questions, just write. He wrote, fair enough, thank you. Okay, the one from Eva, if the team have to split items for small enough to fit in one day of work to use this system, then how can we use this data to forecast items in the product backlog? Do we need to have already refined items in terms of size in the whole backlog? How to maintain such detailed backlog, or how to forecast bigger PBIs?
Yeah, that's a very good question. I'll answer that question by addressing a slightly different problem which you will have. So in many teams, not all teams, but in many teams, they won't have stories in the backlog. They might have fuzzy ideas, one-line items, epics, features, and stories. There's no way you can expect those to be of the same size. No way, it's not possible. However, once you've delivered a couple of epics, you pretty much know how many epics per unit of time you can deliver. And that's what I got started, by the way. The first no estimates project I ever worked in, I was working with 100 teams split over 4 continents. As you can imagine, it's quite hard to even get estimates from that kind of project. Like, can you imagine asking 100 teams to go and estimate all of their backlogs? It's not possible. Also, because the backlogs are changing so fast that the estimate would be completely useless 2 days later. So what I did, very simply, I looked at the backlog and I looked at the epics or features. We were actually following the throughput at feature level. The epics or features, in this case, features that they had in the backlog. And I looked at how many features per week, because, you know, when you have 100 teams, they are not all synchronized. They're not all running 2-week sprints. Some were running 3-week sprints. Some were running 1-week sprints. Some were still doing waterfall, right? And I looked at their delivery rate independently from the method that they used, but of course with one key aspect, which was the delivery rate to a test or almost like production environment. That was very important. And the reason for that is very simple, because a team saying that something is done is a fake number. It's only real when somebody else has used it. That's very important, right? Throughput is always measured beginning to end. It's not measured somewhere in the middle when the team says, oh, I'm done. Well, if it hasn't been system tested, it's not done, right? So that's an important point. But for that kind of project, it would have been completely impossible to know the story throughput. Not possible at all. So what I did, I looked at the system backlog, so the backlog for the whole 100 teams, and I counted how many features they had. And I counted how many features they had delivered per unit of time. And the same thing can happen in your particular context. So while one team may want to split their items into one-day items, like this one that I have in the presentation, let me show that to you again. While this team may want to split their items into one-day items, other teams may want to have 2 or 3 or 4 or 5-day stories. it doesn't really matter. What matters is that you're measuring the throughput at the system level, not at one team level, but at all teams level. Or in the case of you only having one team, you may want to look at story throughput, not item throughput. You know, items could be anything, could be bugs, could be change requests, could be support requests, could be anything. I don't know what your teams have as items, right? So that's up to you to understand. But when you're looking at the backlog, typically you're interested in the story throughput, or as I said, feature or epic level throughput. And that's what we look at. So when it comes to the whole backlog, obviously, if you want to know when epic X is going to be delivered, you want to have throughput at epic level, right? So that's something that you need to build. Now, for an epic delivery timeline to be relevant, of course, you need to have more than one or two. So I'm assuming your backlog has like 10, 20 epics, right? Because if you only have one or two, it's simple. It's not done now, it's going to be done next. Like that doesn't matter, right? It becomes a much more important question if you have like, 4, 5, 10, 100 teams and you have a collection of, I don't know, 200, 500 epics.
Okay, thank you. And Carol, you raised your hand and I guess you want to ask a question.
Yes, but to be honest, there were some questions in the chat that were asked quicker than I raised my hand. So I think from Tomasz Skalski, at least, he was quicker than me.
Okay.
But Tomasz's question is really similar to the one from Eva. So go on, and I will wait for a reply from Tomek if it's fine.
Okay. I was a little late, so if the question is too basic, please let me know. But my question is, I guess your method is to divide stories or items into one-day things, right? A thing that will take one day, and then to measure throughput, if I understand correctly.
No, the method is to measure throughput at whatever level makes sense in your system.
Okay, but how can you measure throughput if one story is going to take 5 days and the other is going to take one? So...
The throughput doesn't care. Throughput is a mathematical concept, and it basically tells you how many items on average you deliver per unit of time. You can measure the weekly throughput, the monthly throughput, the sprint throughput, the daily throughput, the hourly throughput. That's up to you.
Okay, but if you deliver 2 items through a defined period of time and these items are big, then you've delivered 2 big items. But if they're small, then you've delivered 10 small items. So how does that, you know what I mean?
Yeah, I know, Carol. And what I tried to say is that it's up to you to define what you're measuring, but it needs to be comparable to what you have in the backlog. So it doesn't matter if you deliver 2 small or 2 big, if in the backlog you have a mix of items that is of equal size than the ones that you just delivered. And because the backlog is known in advance, I mean, it may grow or it may shrink, that's up to you. It usually grows more than it shrinks. But because the backlog is known in advance, you can then use the throughput information in order to project these lines. Okay. That's what matters, right?
So the method is to have similar sized items then? That is
no, I'm going to explain this again. The question you've just asked, I've been asked 100 times. I know it's hard to understand, but once you start using it, it gets pretty obvious pretty quickly. But the method is not about defining the size of the item. The method is about counting the items. And because the items will be always of similar size, unless some big changes happen, like, all of the product management team goes away, or there's a new lead architect or whatever, right? Like if that happens, yes, there might be some significant changes. But if that doesn't happen, right? If let's say the requirements definition system is stable over time, you will get a mix. And I write about this in the book. You will get a mix of sizes. Some will be smaller, some will be bigger. And over time, when you have enough data, it doesn't really matter because you have a Gaussian distribution of the size of items. So it doesn't really matter in the end if the 2 items you delivered today are small. That's fine, but the 1 item you delivered yesterday was big, and now you have an average of 1.5. So over time, the size of the items themselves becomes irrelevant as long as there's no significant changes in the system. I'm assuming it's the same people working for more than 1 sprint on the same product.
Okay. I needed some time to wrap my head around this because I'm thinking, I get the Gaussian distribution of the items, I get that, but then, yeah, it's just...
Just think about this for a second.
Mhm.
It's impossible for a team during 3 years to have items of the same size.
Yes, but they can be of similar size, maybe. if
No,
that's within
well,
the
but
size.
it's impossible for you to say that.
Yes, unless it's going to be your goal to make it so, right? You're
Yeah,
going
but
to
it's not.
artificially divide them.
But
Okay.
it's not. It's not.
Mhm.
And the same thing happens in network. Packets in the network are not of the same size.
Mhm.
But the throughput already incorporates that information. The throughput is a system performance metric. It already takes into account the normal variability of size of items in the system. Throughput is a system metric. It's not a detailed analytical metric. And that's a very important concept. Because if it were an analytical metric, then the detail of the size would be important. But because it's an outside-in systemic metric, performance capacity systemic metric, then at that point it doesn't matter what the size is, unless, as I said, there are some significant changes. So if the IP protocol packet size would change, then the throughput would change as well.
Okay, thanks so much. I'm going to give the time to other listeners. Thanks so much, Vasco.
Okay, so we have one question from Tomek. He wanted to have a clarification. So here you go, the question. So, oh, Tomek, you can ask it yourself.
Yeah, I can clarify. Hi, Marcin. Hi, Vasco. Nice to meet you. I actually read your book when it came out originally, I think in 2015 or something, and tried to implement the method, and I failed miserably back then. But I was also a very inexperienced Scrum Master. But my question is about actually something different. So I think this premise that we know the number of items in our backlog in advance, this is, I think, something that is for me hard to agree with, especially on a big project. Because this is, I think, whether we use story points or not, whether we estimate or not, this is the biggest problem, that we actually don't know the number of user stories that the epic is going to have. And if I can agree, that at the story level, the throughput makes sense, I think measuring throughput at the epic level, this feels problematic for me, because some epics, can take like, I don't know, a month, but some may take 9 months, right? So this is not exactly enough for the business from my experience.
Yeah, that's a very good point, Thomas, and one that I've addressed already, if not in the book, at least later. So first thing is, you never know the size of the backlog in the future. And if you know, if you read the proposition clearly, it says, we know at all times, meaning in the present time, we know how many items there are in our backlog. Can we agree on that?
Yes.
So if you know the items you have today, you can draw the lines. If the backlog goes up, meaning more items are added, you can still draw the lines. If the backlog is reduced, you do scope management, you can still draw the lines. This is a very important aspect. I'm not arguing, and I don't think anyone could argue. In fact, I've already said the opposite here today. I'm not arguing, and I don't think it's fair to argue that you would know the exact size of the backlog when you start the project, meaning the exact size at the end of the project when you start the project. You can't know that. But you can know what it is today. And because you can know what it is today, you can project the lines and you can start doing the most important activity, which is scope management. See, one of the things that people get hung up on, and that's because of the legacy of estimation, people get hung up on the idea that no estimates is about predicting. Well, no estimates is about not needing to predict. No estimates is about a constant adaptation, constantly inspecting and adapting so that you can deliver on time. If we can do the burn down, and if we can project our lines, and if we can remove the scope, or at some point even add the scope, in order to deliver on the time that we accept as acceptable, then obviously, then we can deliver on time. The only difficult thing is, as I said, and also the most important thing is, how do we manage the scope? So that's point one. Point two is, well, one epic can take 1 month and another epic can take 9 months. Well, that's a big problem, but it's a big problem not because of the epic itself, but it's a big problem because that's totally useless for the management of work. Now, I understand why some managers would like to come up with a one-liner typically, like I remember a couple of those. One CTO once came to me and he said, we want to be the Apple of computer security. Now, okay, now go write the epics. Like, what do you mean? That could mean anything, right? Does it mean that we want to have the most beautiful user interface? Like that, there's no meaning to that. Now, when those epics last 9 months, is because there's no work going into refining the epics so that they have a meaning. And there's two kinds of meanings. One meaning is, what does it mean? Like, what are the features that we will eventually need to implement, or even the stories? And then the second meaning is, what does it mean for work management? So here's a tip you can take to the bank. Whenever an epic lasts more, and my rule of thumb is, 1 story, 1 sprint, 1 feature, 1 month, 1 epic, 3 months. When an epic reaches the end of the 3 months and it's not completed, well, you just got information. The system just told you, you predicted incorrectly the size of the epic. What does that mean? You take the epic, you split it in 2. You consider part 1 done, and you add a new epic to your backlog. So now your backlog just grew. Now you can quickly see that an epic that would last 9 months would be added 3 times to the backlog, and therefore increase the size of the backlog 3 3-month periods in a row, which would extend at least the project 3 months every 3 months, right? Assuming the epics are limited by definition, not by estimation, but by definition, to 3 months. Now, this is an expert tool. Like, I don't expect people to know about this, because we've been indoctrinated by people who knew nothing about agile estimation and planning, that epics could be of a random size. The same thing has happened to stories. In fact, most of the agile estimation and planning books out there are complete bollocks. They are completely wrong. In fact, I could show you a couple of examples of somebody writing an agile and estimation planning book. I won't mention names here, but somebody writing an agile estimation and planning book and pointing to a new way of planning stories. And in fact, what he's writing down is a PERT chart. The PERT chart is a very traditional tool for waterfall project management that identifies your critical path and allows you to make decisions planning-wise that affect the critical path. And for those of you who know the critical path, you already know that's a very important thing to know. Now, in Agile, we don't have critical paths because we can release at any time. At the end of a sprint, we can release. So we have the possibility to manage scope aggressively and from the start. And that's the key aspect of no estimates, right? Is giving you the option to say, no, we release now. Let's not add more things, right? Including the basic idea of splitting a story. Think about this for a second. If you have a story and you split it into 2 stories, you now have the option to work on the first part of the story and not deliver the second part of the story. You can do this recursively. You can do this for a story, for a feature, for an epic. And that's what we are trying to get at, is constant inspection and adaptation of the scope so that we deliver on time. And that can only be done if we're looking at our rate of progress and the size of the backlog. And that's what this image is all about.
Thanks.
Thank you.
Thanks.
Okay, Karol, before you will go, one question from Jacek. So how does framework cope with the black swans? It's probably more philosophical thing, but if you believe Taleb's idea, predicting future with data from the past never really works, So just for people who don't know, black swans, it's Nassim Taleb's idea of situation with high impact that are really hard to figure out when you start to think about something. Okay.
Yeah, I would add to that one aspect that doesn't often get a lot of publicity, but it's very important in Taleb's work, which is the fact that we live in a complex world also means that small changes in the past can have major, even catastrophical impacts in the future. Some people might know this with the term butterfly effect. This comes from complexity science, and it tries to explain that small changes in a complex system, small changes amplify throughout the system and can lead to catastrophic effects. And this is very common in scope management. I'm sure that many of you will remember a case in your career where a small innocent decision early in the project kind of ballooned and ballooned and ballooned, and actually that small little decision of supporting platform X, as an example, actually completely destroyed the project. I remember once being in a project, some of you might not even be old enough to know about this. If you are old enough, you will know what a compact iPack was, which was one of the first mobile computers running on Windows Mobile, one of the first multi-purpose operating systems for mobile devices. And we had to have the damn device in the fridge because at ambient temperature, the device would crash every 20 seconds. Now, can you imagine trying to get your developer and tester teams to work inside the fridge? That's the problem we had to solve. And that was a very simple decision. Let's support the compact iPack, right? That was a simple decision that had a massive catastrophic impact on the project itself. So that's the idea of the black swans. And I think that's a great point that you raised. How do we survive black swans with this? Okay, so obviously no estimate is not about predicting black swans. In fact, the idea of a black swan is that it cannot be predicted. But here's the thing, when you're at this point and you see, the project has been quite flat for a while, and then you start to see this dynamic, right? And I'm sure some of you have seen this. I have seen this in several projects. And when you see this dynamic, you go like, okay, what's causing this, right? We're a few sprints into the project and the backlog is going up instead of going down. And now it's up to you to look into the details and to do what we've already talked a lot, and which is the only tool we have to deliver on time, is to do scope management. And this can be done at many levels. It can be done at story level, as I illustrated here. It can be done at epic, at feature level, can be done at platform support level, whatever level, right? The scope management concept is a fractal concept. It applies at all levels in the project. So you have that opportunity. And what No Estimates is about creating a system that delivers this kind of information. Whether you want to listen to it and act on it or not, that's up to you, right? And sometimes not even up to you guys that are here, but up to the CEO or whatever of the company. And that's what we try to do, is to create a system that allows you to have information you trust, that allows you to make decisions. Don't forget, and this is a very important aspect, don't forget that if you're close to the end of the project and you're here, you can still add scope. But if you're at the end of the project and you're here, it's going to be very hard to remove scope. And the reason for that is simple, because there's a lot of expectations and dependencies already created in the work delivered from the beginning of the project all the way to this point. So the longer you go in the project without making a scope management decision, the harder it gets to make scope management decisions. And No Estimate is all about creating that space and the data to have that conversation. If you go to a client or to a manager and you present this kind of information sufficiently early, and of course, and they believe it, that's another point. But if you can present it sufficiently early, you can do a lot of work on the scope management front and still deliver on time. And that's really the key.
Thanks, Vasco. Karol, maybe if you can.
Yeah, if no one is against, because that's the second time for me. So could you elaborate a little more on the rule of thumb you described? So story is for a sprint, feature is for a month, and epic is for 3 months. How does that relate to the throughput and everything else?
Yeah, so the idea is when you stipulate, not estimate, but stipulate the size of an item, what you create is an information gate, right? So at the end of the sprint, you either delivered or you didn't the story. Now, if you were doing what most teams do out there in the world, you just pull the story into the new sprint. And that gives you, from a data perspective, zero information about what just happened. But if what you do is, I take the story at the end of the sprint, I consider one bit of it done, maybe only a few of the acceptance criteria, and then I create another story with the rest of the acceptance criteria. Now you have 2 pieces of information. You have the first piece of information is what's a size that fits into a sprint. You may look at it or you may ignore it, but it already tells you that. And then the second piece of information is that your backlog just grew. And of course, if you just take the throughput idea, right? So if we look at the rate of delivery as one piece of information, and then the size of the backlog as another piece of information, now what you're doing is that you're telling yourself, okay, so if this story is pulled, so one more story added to the backlog, that means that the backlog is now of a higher size, right? And if you just draw the lines, you get, at least in theory, a 1 sprint longer delivery. If you do it at the epic level, you get 3 months. If you do it at the feature level, you get 1 month. And again, these are my sizes, right? That's the rule of thumb, or a heuristic, if you will. But you may want to choose different sizes. That's okay, as long as you stick to them.
Okay, but that would then still revert me to one of my previous questions is, let's say you have a period of time and you see that you delivered 20 items, let's say on a story level, and 19 are small and 1 is big. What does it give you though? If
okay,
you see 19,
so,
but
Karol, I would welcome your question once you have had a chance to read what throughput is, because that question is relevant only in the context where throughput has no meaning, because throughput already contains information about the average size of the items in the system. So that's really a question about what is throughput, and throughput is the number of items independently of size delivered per unit of time.
Okay, fair enough.
So Karol, imagine that all of your items have a ratio of 20:1 on average in your work. And you know, if you're talking about numbers, the more numbers you will get, the more predictability we will get. I mean, we're not talking about predictability straight off, but this is how I see it.
I think that the throughput is a very important concept here, and that's, I totally accept, a concept that I cannot explain very well, especially in this kind of setting. So that's something that I think would require a little bit more reading. And if you have read the book, it has some information on it. And we talk about sizes specifically in the book, and why the size is not that big of a problem. In fact, in throughput, it is no problem at all. But if that's not enough, then just contact me over email, and I can give you a few more references. But the concept of throughput here is extremely important. All right, I think we're getting close to the end, right?
Yes, we do. And I wanted to encourage us for the very last question. So take a chance, ask Vasco a question, the last one.
So if I may, that's something from the advertisement of this particular meeting. So when it has been advertised, it's also, there's Vasco, there's this question coming from the business. So when it's gonna be done? So when that pops up and you don't have yet data, you didn't start any sprint, so there is only a draft of a backlog, how would you react, and what would you say? And
Yeah, I mean,
the lines. So that's what I do also for velocity. Maybe I'm blasphemous right now, but I have also this positive and negative scenario, right? So it's always a compartment, something in between. That idea I get, but
yeah, the problem with velocity though, Yaroslav, is that you need to have had estimations for all the items in the backlog. And that's what we're trying to avoid. So throughput is independent of whatever size or estimates you will give the items in the backlog. So as long as you're using something that is based on an estimate, so velocity, meaning story points or t-shirt sizing or whatever, as long as you're using information that requires all of the backlog to be estimated, you're in a catch-22. So you can't answer that question if you're using velocity.
Yeah, that I agree. My question was rather, what do you say when you are in a point at the very beginning of the project, you don't have your data yet, you don't have throughput, and the customer, of course, you're signing a contract, and customer requires a deadline.
Yeah. So those are two different problems. So the contract problem, I just picked a book called Extreme Contracts. You want to look at Jacopo Romei's work on extreme contracts. And the reason for that is that the contract problem is a totally different problem from when will it be done, right? And I can't explain all of the details here, but Jacopo does a great job of explaining what a contract is all about and why they are there. And it's not about setting a deadline. The deadline is part of the conversation, but it's not why the contract is written. There's a bunch of things. And he gives you several types of contracts that work perfectly for the intended purpose and have no deadline associated, right? So that's one problem. The problem of answering when will it be done, here's the thing. Can you tell me what needs to be delivered? Because if there's no hint of a backlog, the answer to that question is, well, until we know what needs to be delivered, there's no way we can know when it's going to be delivered. Here's a tip though. In the No Estimates workshop, we actually do that, but we do that with a trick. And the trick is you can set a deadline and then decide later on what can be delivered in that deadline, right? Once you know that the deadline is here, you can manage your scope in order to hit that deadline. That's again going back to the key aspect of No Estimates, which is to enable scope management conversations, right? But this is not what the question that you often get asked. But I do have a video of that in the No Estimates book, the paid version, which has 9 about 1 hour video interviews with people that have answered that question that you just asked. So, you know, how do I make a fixed bid project, a fixed schedule project bid when I don't even know everything that's going to be there? So there's some people that run their own businesses, right? Software development businesses, explaining how they do that, their own approach to No Estimates in the contract phase. And in the workshop, we talk about a different aspect, which is define projects around value rather than scope, so that you can vary the scope and still deliver the value you need to deliver on time. But that's an advanced topic. That's something we would need a lot more time and a few hands-on exercises to go through.
Of course. Thank you.
Okay, thank you. So it was almost the last, because in the meantime, there is really the last one from Maciek, and I know that we are run out of the time, but I want it to be answered, and please no more questions. So do you have a rule of thumb of how is an episode of your podcast needs to belong to end in throughput 5 episodes per week? I don't know if the question is clear.
Yeah, so here's the thing. When I start the podcast recording, I always know it's going to take between 1 hour and 1 hour and 15 minutes. I know that because I have 370 podcast sessions done. But here's the thing. When the next session starts, I don't know if that session will take 1 hour to 1 hour and 15 minutes to record, because it's a new session. It's in the future. So what do? I give myself the rule of thumb I talked about. Every episode should last between 10 and 15 minutes. And if that's the case, I know that the all week of episodes will last, in terms of recording, between 1 hour and 1 hour and 15 minutes. So what do? I let the first episode take as long as it takes. And at the end of the first episode, I ask myself, how much time do I have left? Right? Same thing I was just talking about. How much time do I have left? How many episodes are left? And how long do I have per episode so that we can still end the recording within 1 hour and 1 hour and 15 minutes, because the guest needs to go to the next meeting. So what I do is dynamic size allocation per episode or per segment to make sure that we stick to the schedule that was defined about 2 years ago. So that's what we do. And that's what we do in software projects as well. How many items do we have in the backlog? How many have we delivered so far? So what's our rate of delivery? And what does it look like we can deliver until the deadline is here? And that's it.
Okay, thank you very much, because we started on time and we also want to finish on time. So Vasco, very thank you. I hope you enjoy the time. Thank you for sharing all of the knowledge, answer all the questions, and I hope all the attendees also liked the time. So thank you very much and have a great rest of the year.
Thank you, everybody. Bye-bye.
Thanks a lot. Bye-bye.
Thanks.
Thank
Thanks
you.
a lot.
Bye-bye.
Thanks, bye.